In part B, we determine how long will it take for the investment to triple. So we have to find the time it takes for the amount to grow to the three times of the amount invested in the beginning. That is when A becomes three times of P. So this equals the amount invested is three times of 2000. And so when the amount becomes 6000, we have to determine the corresponding t. So let's use this amount compound interest amount formula. Let's plug in the values. First, let's write this amount equation. So A equals P is the amount invested, which is 2000. So I put 2000 times 1 plus R is the rate of interest, and this has to be in decimal. So R equals 7.5%. Let's put this in decimal. So it is 7.5 over 100, and so this equals 0.075. So I put 0.075, and this is divided by n is the number of compounding periods in units of time. That is, in 1 year, it is compounded quarterly. So it means there are 4 quarters in an year. So n basically equals 4. So I put 4 here. And this has to be raised to the power of nt. We know that n is 4. And we should determine t here. So I put this as t. Now let's put a equal to 6000. So I replace a by 6000, and this equals 2000 times, we will simplify this quantity, that is 0.075 divided by 4 equals 0.01875. So I put 1 plus 0.01875, and this is raised to the power of 40. Now we can add these two. So in fact, I can also divide both sides by 2000. So I divide by 2000, and so this side I get 6000 divided by 2000 is 3, and so we get 3 equals here we get 1, and so I just put the numbers inside the brackets, that is 1 plus 0.01875 equals 1.01875, and this has to be raised to the power of 40. Now we have to solve for t, so we can apply the natural logarithm to both sides, and when we do that, we get natural logarithm of 3 equals natural logarithm of 1.01875, and this has to be raised to the power of 40. Now, using the properties of natural logarithm, we can put this expression in front of this logarithm. So in the next step, we can write this as, we have a natural logarithm of 3, and this equals 4t times natural logarithm of 1.01875. Now to solve for t, we first divide by this expression. So I divide by this expression. So I get natural logarithm of 1.01875. Sorry, this is 5. And this equals 4t. We will divide this 1.01875. So these two natural logarithms will get cancelled on the right side. We can rewrite this. I rewrite in terms of 40, and this equals natural logarithm of 3, and this is over natural logarithm of 1.01875. And now we have to solve for t, so we divide both sides by 4, and so when we do that, we get the equation for t, that is t equals natural logarithm of 3 divided by, I can put this divided by 4 as 4 times of natural logarithm of 1.01875. So this is the expression that we get for t, and we can plug this expression into the calculator, and when we do that, we approximately get the t value as 14.79, and this is approximated to 2 decimal places, and so this is in years. And so we can say that it takes 14.79 years for the amount to triple. So we write it takes 14.79 years for the amount to triple.